And welcome everyone. Thank you for joining us for today's session in the AI Inequality African Toolbox series. This is our fifth webinar and it's going to be an exciting conversation. We're thrilled to have you with us to explore how AI can advance equality and human rights through African-led innovation. As you may know, the African Toolbox builds upon the Global AI Inequality Human Rights Toolbox, which is an initiative of Women at the Table and the Center for Technology Studies, ACTS, in Kenya, but it's also in collaboration with the United Nations Office of the High Commissioner of Human Rights. And it's really designed as a strategic and practical resource for policymakers, technologists, civil society actors, and communities across the continent. And basically, the idea is simple, but it's really transformative. It says, and it's premised on the fact that Africa's relationship with AI must be defined not by adoption alone, but by ownership, co-creation, and leadership. Because for too long, technological systems have been imported from elsewhere and have often been built without consideration for local context, for culture, or lived realities of various African communities. And the African Toolbox is basically our response. And it's built on the conviction that AI can and must be developed with equality and human rights at its core, which really can ensure that innovation strengthens rather than undermines human dignity and agency. So the toolbox is built around a life cycle of 6 stages, from defining the problem, designing and developing systems, to testing and evaluating outcomes. And so, as I've said, this is the 5th session, so we're looking at the 5th stage, which is testing and interpreting outcomes. And this is the point in the life cycle where we really ask, does the system truly serve the communities it was meant to empower? And to explore this, we're turning to a really powerful homegrown example from Code for Africa, which is the Sensors.Africa initiative that uses AI to transform environmental governance and community advocacy. And our guest is Alicia Olago, who's an environmental scientist and the senior product manager of Sensors.Africa, which is among the core projects for Code of Africa. So her team has developed low-cost, AI-enhanced climate and air quality sensors that enable communities across Africa to collect, interpret, and own their environmental data, which means that they've shifted the balance of power from institutions to the people who are most affected. Alicia, it's a real pleasure to have you with us. Welcome, and thank you for being here to really share the story of Sensors.Africa and how it's redefining data justice and equality in the African AI landscape. And it's really exciting that we have Prof. Winston Ojenge, who's the Principal Research Fellow and Head of ACTS AI Institute, in conversation with Alicia. So I just want to do a little more framing before we dive into what would be a really exciting conversation. So as I've mentioned, there are 6 stages to the AI life cycles that really help us think critically about how to design, deploy, and govern AI systems that center human rights and equality. And stage 5, testing and interpreting outcomes, is a crucial phase that goes really far beyond technical validation. So this stage is premised on the praxis that testing takes place in real community contexts, not in isolated labs. It combines technical evaluation, checking for the accuracy, reliability, and transparency of the model with community feedback to really understand how do people actually experience and use the system. And it's also the stage where affected communities have their final say, what we call in the toolbox the sign-off moments, where they can confirm if the promises made during design and developments were eventually fulfilled in practice. So in other words, I guess stage 5 is where AI accountability really becomes visible and where empowerment, transparency, and justice are actually tested in real life. So that's exactly why the Sensors.Africa initiative is such a powerful example for this stage. It demonstrates what it looks like when testing isn't just about algorithms and software, but about agency, and agency where communities can actually validate, interpret, and act upon the data that affects their life. So with this framing, I'm going to hand it over to Prof. Ojenge and to Alicia to explore how this process actually unfolded in practice and how communities became co-testers, interpreters, but also ultimately co-owners of this AI-driven environmental data. Over to you.
Thank you very much, Amina, for this opportunity and for the lovely title you've given me. Welcome, Alicia. It would certainly be exciting to hear your thoughts about some of these curiosities we've heard about AI systems as applied in Africa. Let me start by just being curious whether you can share what first motivated you and your team to focus on air quality monitoring in African communities. Why did you see this as a justice issue rather than just a technical problem? Okay.
Thank you both for the warm welcome. And if I can respond to that, the African continent, right? It's the least developed continent, but at the same time, it's also the one that's urbanizing the fastest, which means that every other issue, any similar issues that we have seen from whether it's the global north, they will begin to happen on our side. And we would imagine that they would be 10 times worse because of the urbanization rate and, of course, the high population rates. And that was really the idea why we had to actually focus on air quality. And aside from that, within this high population rates, there is a lot of marginalization, right? And in the air quality space, low-income communities are disproportionately affected by the air quality levels. These are the groups that are going to be cooking with firewood in their houses. So we just imagined that if this is a conversation that the World Health Organization is quite worried about, how much worse will it be in the African space where we have larger populations who are low income, who will actually be struggling with this problem and have no idea that it's actually happening to them.
Yeah, great. So that is very, very illuminating. I know certainly there's been a lot of value that your work has added to a discourse that has been public for very long. We know pollution has been topical in public discussions, in reports, with the journalistic, etc. We also aware that journalists being, having to contend with many topics, they've likely struggled, to be able to report, the technical component of the reports on pollution. And we wonder whether your work at sensors.africa has been able to shape how journalists report, whether it's been able to address the struggles they have with reporting such a technical issue. And if at all, your support of their reporting has influenced the design of the sensors themselves.
Okay, I would say yes, our data has and is currently used by journalists the most. And I say this because one, as Code for Africa and Sensors Africa as well, we are an open data, open knowledge space, which means the data that we put out is for the public. And everybody knows that the people who have the highest audience and the largest number of audience will always be the media. So it's important for us to be able to give them that technical support to be able to understand. And then again, they've been trying to write this type of stories if they're reporting about an industry or a factory or any polluter who is actually emitting some kind of effluence into the environment. It's actually crucial that they have some evidence of this. Otherwise, it is hearsay, and they can actually be liable and have issues and maybe be sent to court or something of the sort. So it was important to make sure that when they want to write a story about a factory, we can actually set up a sensor there with the community, and at the same time collaborate that information with the community that's actually experiencing those poor air quality levels. And I would say that this has absolutely influenced the design of the sensor. And this is because with the vast spaces that we have in this continent, and again, with what I mentioned about urbanization, there's a lot of industrialization that's going on. And there's also a lot of urban challenges like mixed land use, right? So you will have residential areas where there are factories and that type of thing. And having an affordable low-cost sensor, something that's $300 and not $30,000, allows us to deploy as many sensors as possible and support a large group of communities as opposed to having expensive sensors. So yes, the journalists definitely played a role in influencing on the design.
Yes, I totally agree with your continental impact. Actually, how we came to get to know about yourselves is what we realize is the power of your technique, use of very low cost devices to do this data collection. Can you explain briefly how these sensors work and why you think they're suited to the local African context?
Okay, so our sensors, as we've said, they're low-cost sensors, and they're powered by, of course, there's an IoT aspect to it. And this just basically means how they communicate. And if I can speak to how they work in the African space, this is more so around the conversation of the fact that within this continent, at least half, I would say around 600 million of African people do not have access to power from the grid, right? So electricity is a big challenge. Now, for these devices, they need either to be connected to the mains power. So similar to a phone, you'd need to connect it to power. They also use a SIM card. So very, very similar to a phone again. They have a SIM card inside of them. And then, of course, you have the sensors inside there that are either collecting particulate matter. Of course, temperature and humidity has also to be collected. But the idea of how we domesticated it for the African continent was, one, we know that we are going to have so many places where we'll not be able to connect to mains power, and especially in remote and rural areas. And for this reason, we chose to include a solar panel on the device. And this means that no matter what, the batteries that are inside that device are constantly charged. So it works with the solar panel during the day, and at night, when the sun is gone, it uses the reserve that has been stored within the battery. And that means that, one, we don't have missing data gaps. It also allows us to have data from areas where it would not have been possible. Aside from that, we previously used a GSM SIM card, which is the SIM card you use on your phones. But we realized that in some places, and I think everyone has experienced this, there's pockets of gaps of communication for different networks, whether it's MTN in Nigeria or Safaricom here in Kenya, whichever network it is, you will find areas where the connection is not as powerful. So we thought it would be better to incorporate what we call an IoT SIM card. And this actually works on roaming. So if you take it to a specific place, it's actually going to pick up what is the strongest in that area. And that already eliminates the challenge of losing data because a specific network is not as powerful in that region. And I would say those two are the key things that we have done in the device itself to ensure that we can share this, we can have this data in the different spaces.
Yeah, very, very, very impressive. Before I shift gears, maybe I could ask one more question, and this is about the direct impact on health of air quality. We know the impact is massive in certain instances, yet invisible, and even worse is that it's invisible to community members, to the general citizenry. How did you ensure that the data collected was meaningful and actionable, for the communities themselves?
That's a very good question. So first and foremost, for us at Sensors Africa, it's very important that we have the community as a partner. That is the first thing. And aside from ensuring that we educate them, it also helps us ensure that our devices are safe. So I can just add that in there. That's one side of it. But before we do any kinds of deployment, we always use participatory mapping, which has been very instrumental in ensuring our sensors are safe and we get that kind of trust. Now, within this aspect of participatory mapping, it's really just us having a small meeting. It could be under a tree, it could be in a tent. We just ensure that we have ambassadors and a fair representation of community members in that particular area. And what we do is we print out maps of the area. Say, for example, if the area is called Kibera, for example, which is an informal settlement in Nairobi, we'll print a map and have everybody there interact with that map, right? Once they interact with it, we ask them, what environmental challenges do you have? Can you pinpoint on this map? And with that, that actually helps us deploy the sensors. Now, that first interaction already has brought some kind of sense of ownership to them because they probably live there. Maybe their child is next door and all that. And we will tell them, okay, I see most of you picked this specific area next to this place. What happens there? Can we have a conversation? And they will say, at night, there is some smell that is around here, or the children who live around here are always coughing, and that type of conversation. And then we now explain that this device is meant to get us to understand how the air quality is in their community. And with that, we can have evidence that can be used to actually support them. And so this is just, it's a kind of exchange that we have with them. And it's really, I would say it's really helped them to understand that they have that data and they can use it. And the interesting thing is most of them know that they should not be having that type of air quality level, but what they don't understand is the sources, right? They would never understand that open waste burning is why that's happening. They would never think it's a factory. They would never think it's them when they're cooking, right? We need to get them to understand the relationship between those two things. And then having the data and showing them that, look, this always is higher between 5 and 9 p.m. What are you doing in the house? I'm cooking. Then they can understand that the air quality level is actually related to what they're doing, and that the data we have can actually help them advocate and also just change their behavior in general.
Yeah, that is quite true. Very precise. Now, shifting gears, Alicia, let's speak to the testing and workability of this infrastructure. So once you have had the sensors designed, deployed, of course, the next challenge is making sure that the AI models developed from this sensor data actually work, and that it served the people that it was meant to empower. This brings us to the second part of the conversation, and that is testing and interpreting the outcomes. How do you validate that these sensors were accurate and reliable in real-world community settings, beyond the lab? Do they really work? Do they really deliver what they promise to deliver?
I think I can give an example of an ongoing project where we are actually trying to use, of course, AI to have like early predictions of air pollution levels within a secondary city in Kenya known as Nakuru. And what is currently going on is we are working with the climate change ward committees, which are set up across the whole city itself. And we have representatives there who we engage almost every day, I would say. So we have a knowledge broker who is part of the larger project. This is a project that has a consortium as well. But of course, since we are the data service provider, we are part of this conversation. And we are constantly talking to them, constantly trying to understand Have you looked at the air quality in your level today? And how are you relating that to what you told us? You are the ones who asked us to place the sensors in these specific areas. Does it speak to what you are saying? Is it, are you seeing the levels changing based off the times of the day that you had communicated? You said that there's a dump site next to you. Can you correlate the time when the dump site is burning and the air quality levels at this particular time? So we've been having those kinds of conversations with them in the different spaces. And it's interesting to see that some of them are actually over monitoring, if I can use that word. So they are constantly checking and reporting and saying, yesterday was higher than this day. And they are going on the ground to also go and actually check and see, is what they said happening? Is this the reason why this is higher? So there's that type of conversation that's going on. But the whole idea is just to ensure that they understand eventually this information that they're giving us, this data that we're getting, we're using them as human sensors, I would say, but we also have our sensors that are the actual physical device. So putting all those conversations together will then be used in the future to test and see whether the alerts work, whether those alerts are actually timely, and whether they're able to respond to them, because they should be able to report and say, this factory is always emits on Wednesdays at 10 p.m. in the night. And they should not be working. It's not office hours. And also, why are they polluting the environment? But with this type of engagement of them being a human sensor and having our sensor and having that conversation with them where they are looking at the data, it's supposed to help the testing and designing of the tool itself, which is going to use a lot of modeling, of course, and algorithms to be able to do the prediction of the air pollution levels. And aside from that, we've actually, as part of that project, made an app. And again, of course, that app is what is going to be used for the prediction. So they should be able to download it, and they should be able to get notification that says probably the air pollution levels at this point in the day are too high. And then with that, they can either mask up, or, if there's children, people in schools know what to do. You're able to report. So I would say that's the whole idea around looking at how we ensure that we've accommodated all this accommodated, of course, the AI aspect of it, and seen that we are testing it to the community so that we build a tool that actually works for them.
I think Prof's intranet might have some challenges. Perhaps oh, my internet is also dodgy. Sorry. Yeah, I'd be keen to ask you a few questions. In the meantime, Alicia, I'm really interested in the type of data that Sensors.Africa collects, and if you could perhaps give an example of how the sensors have revealed air quality issues that were previously undocumented or even ignored by authorities.
Great. I actually have a very good example for this one. So we had a community, like I said, for us, our sensors are to provide data to the public, support everyone and anyone. So we had this residential area, some apartment blocks that reached out to us because they were really concerned about the frequency of coughing and pulmonary diseases that children were having, even adults, within their area. And I think someone informed them about us, and of course, we interacted with them. We had conversations with them about what's going on, similar to what I said, the participatory mapping, just to understand what would be the best place to set up the sensor and what exactly are the challenges. And we set up the sensors there, and the data that came out of it, of the particulate matter levels, 2.5 specifically, was actually quite shocking. And it seemed like that community or that residential area had been advocating, had been complaining, had been reporting, and they were really not getting heard, because it could just be that there is bad blood between an establishment and a residential area, not necessarily that there's poor air quality levels. But the fact that we were able to put up the different sensors, and these people volunteered their homes, so the sensors were connected inside their homes, working with Wi-Fi in their homes. This is how desperate they were. And the data that came out of it was so powerful that I'll say one of the prominent media houses in Kenya was actually able to do a full story looking at the whole area, what could be the source, and relating it to the data. And it went all the way to get the attention of the governor at the time, which was fantastic for them, because they had been trying to advocate, they had been shouting about this and nobody was listening to them. But it actually got to the governor and he shut down the factory. But in real sense, this is still just an urban planning challenge, because the area had residential apartments, and there was also someone else at the back who had a factory, right? So the conversation again comes to who came there first. Was it previously an industrial area, and we now have such crazy population growth that you have someone buying a piece of land there? And because of that, this had to go to use our legal system. So it went to the Environmental Tribunal that actually looks at this type of cases to be able to advocate and negotiate and find out what is the best way forward. Because, of course, an establishment like a factory costs a lot of money. So does the residential area. So how do we get to a point where we can actually have solutions? So I think that's one big example I can say where community was being ignored, but because of the data that we have, they were actually able to push their agenda forward and advocate for themselves.
Great. Thank you very much. Thank you, Amina, for filling in. I lost my network there briefly. Alicia, I like really the way, I think it's very powerful, the way your infrastructure has enabled communities, to make industries be accountable for pollution levels that are caused by themselves. But I wonder, your method, we understand it combines the sensor data, which is more quantitative. But I understand that you also employ methods which are more qualitative, like focus groups and interviewed. And I wonder how this mixed methods approach enables you to enhance understanding of the air quality challenges.
I think I've mentioned this somewhere, but let me expound on it a bit better, right? So I think quantitative data is always fantastic, and everyone will agree with that. You can do your computations and you're happy, but how do you actually validate what you have from the quantitative data without having the qualitative data? To be honest, in something like air quality that we can't see, it's crucial for you to have a mixed method approach. It's crucial for you to have that qualitative data that gives you information from the citizens. And as Sensors.Africa, being citizen science, it's so important for us that they are our partner, because as I said, you can sit on a desk and look at a big data set, really big CSV file, and you're very happy with it, and you can see all these levels. But without having those type of questions that have been structured for you to get some insight from individuals in a space, you will not be able to correlate why there are certain trends within your data, right? There is the basic ones that we all know and understand. Like if you're in a city, we know that between around 6:30 to 8 o'clock, we know that particulate matter levels will be very high because people are going to. But what about a rural area where no one owns a car and there's very few factories? You will not be able to understand the source of your pollution without you actually having a conversation with people there, without you understanding that, one, they don't have frequent waste collection services, which means that they have to dump outside, which means they have to burn their waste. If you've not had that interaction, you don't have that call data, you will not understand. You might even think your device is actually malfunctioning, to be honest, because sometimes those levels are quite high. But once you have this qualitative side where you've interacted with them and had this information, you understand so much more. And I think also the beauty of something like a focus group discussion is when you sit down with the women, you understand the trends of very interesting things, such as how they work within the households and how the different aspects and roles of them as a mother or as a sister or as a daughter is fully exposing them to much poorer air quality levels than the men. And this is just because this is how life was set up for them, but they are not aware of it. But when you're having these conversations, you actually relate, for example, health issues in babies, pregnant women. We get that from something like a focus group discussion, because the woman will say, I cook between this time and this time, and we can see she's pregnant, and we are in the house and we can see that they are not using clean energy. So we already know that she's going to be exposed. And that can be, again, collaborated with data from a health center in a specific rural informal settlement, where they'll say there seems to be 50 to 60% of women here having this specific issue as compared to men who have left and gone to work. So I think that is actually the beauty of the mixed methods approach. You get much more insight than you would with the quantitative data.
Totally agreed. You happen to be fortunate that you're engaging in academic research of very high level, but you're also addressing very direct community needs. But again, I wonder how you manage to strike the balance between academic rigor, because I believe that some of the data that you generate used in very many academic spaces, but again, you have the burden of having to address or answer to the needs of this particular community that, for instance, you're serving. How do you manage the balance between that academic rigor and the community ownership, and accessibility of their data?
I think for us, we handle data issues based off who the partner is. And I'll say this, I think the best way to respond to this is, of course, like I said, still open data. So it's available for everyone and anyone. In a case where we have, for example, I can give an example of, again, another secondary city in Kenya, known as Meru. There's a university there known as Meru University of Science and Technology, and we've actually been doing fantastic work with them. But for us, they already know that we are a citizen science initiative, which means that if we are going to do this with you, we need to actually include this component of having the community on board. So who are you engaging on the ground if you want us to do this, and who should we engage? Can we convene everybody together and have a conversation with this? So that's one thing that we try as much as possible to do with academics. But remember, there are some who will come who don't want to do anything with us beyond accessing the data. Like, they probably just want to censor. They have their own independent study that they think shouldn't have anything to do with us. For those groups, we do allow them to actually just take the data, because we look at it in terms of whatever is going to come out of that is going to be so rich for someone else who is planning to do a future study in whatever the theme was. But then there's the other groups like the one I'm mentioning who want to have us as part and parcel. And we work with them, work with CSOs, work with private sector. It was actually, it's a very good relationship because they're also including the county government, they're including the private sector, they're including market associations because we know that markets are again a big source of pollution. They're including transport sector. And from that, we've actually gone to the point that we now have 2 peer-reviewed journals in partnership with the university. And remember, for academics, that's a big win. So we try to also respond to their needs in that way. Like we know they want to have a journal, they want to have a paper. We want to support that because for us, again, once that's knowledge growing, that's knowledge that's going to be shared beyond our data sets that people cannot comprehend. And they're going to support an agenda at the end of the day. So we try to balance it in that way. With the community, we know that 90% of them cannot consume the data as it is. I'll be very honest. That's something we've actually realized. They cannot consume a CSV file. Some of them don't know what to do with it. So you'd have to actually explain to them. And we decided that the best way to actually handle that was to make sure we have data visualization that allows them to see and understand what's going on with the data. And with that, we have 2 options. Of course, it's somebody who is literate, educated. They can read a bar graph. They can see that this is higher, this is lower, so they can understand that. But aside from that, there are people who cannot even interpret that type of data. And for them, we have a graphic map that uses an air quality index that shows you red is dangerous, green means it's good, or amber, orange. And that's actually working quite well for, I would say, specific individuals in the community who cannot consume a CSV file. So the needs are so different. But at the end of the day, we look at who is going to consume this data, how do they want to use it, what is the agenda beyond this, and then we're able to respond to it adequately.
Quite impressive. I think that's a new angle. For me, it's a new angle to the topic of data justice. And I would love to have that conversation with yourself sometime in the near future. Let's shift, I think, the last gears and reflect on the future. What lessons that you've learned from deploying air quality sensors can inform other applications of AI across Africa, but particularly those that are aiming to empower communities rather than simply gathering data for academic purposes? Okay.
I think one key one, I think, is whatever AI models or algorithms or applications or tools that will ever be developed in the future need to have a way where we can incorporate either citizen reporting or indigenous knowledge. And I only say this because I think they will be more robust, right? Because there's a lot of data that rests with the community itself that has not been uploaded to some document, a report by the government, or like basically the AI tool itself cannot be able to access that information. So how I look at it is, if I can give an example of climate and the climate change conversation that's going on in the world right now, in different communities, you'll find the elderly have so much information on how they've been adapting from the past. And some of this information is either being passed to whoever is still staying there, or it doesn't even pass to anyone else because they leave the village and go to the city. And there is information that can actually be used to collaborate conversations around like climate modeling. If we need to look at the history of our data, if you need to look at trends from 500 years ago, you need to also have that aspect of the indigenous knowledge and see what were they doing? Did it work? Because I imagine that later on in the future, if this is omitted, then you'll have a case where we are just repeating solutions that did not work while we could have actually consulted a community member or an individual on the ground and found out that that is actually a waste of time. So for me, that's one really big one, that we need to find out a way where we can have citizen reporting, indigenous knowledge embedded in there. Apart from that, I don't know how this will be done, but I think AI models also need to be a bit more lightweight, and we need to find a way to prioritize some kind of offline capacity, right? I'm imagining a community member who doesn't have access to Wi-Fi, who doesn't have access to data bundles, can't afford that. If we have a tool, for example, if it's generative AI, they're trying to find some information, or even for us, the tool we are building for the prediction of air quality levels, people should be able to use these tools without having to think, okay, I need to go to that cafe and connect to the Wi-Fi, or I need to spend money. So they need to be lightweight, and we need to have some kind of offline capacity. And I think that also goes a long way in reducing the energy aspect that everyone is concerned about when you're talking about AI. Apart from that, I think maybe, if possible, a way to co-design key performance indicators with the community. If there can be an algorithm that also takes that into account, because then it's more holistic, because at the end of the day, the community knows what they need. The community has the lived experience, right? So if they're a partner, like for us, it's important for them to be a partner to us. If there was a way to include that, I think it would be fantastic.
Yeah, I am impressed by the effort your team is putting to be as inclusive as possible. You know, the type of people who are literate, who have smartphones and can easily interpret your data, the kind of people who will need graphics, and you know, your effort at trying now to even be more inclusive of like in terms of engaging community in algorithm development that would then give them the very best that they need. Yeah, I'm hesitating to ask this last question, but I believe that Amina certainly would want me to ask it, because I already see that it's very clear. And reflecting on your journey with sensors.africa, do you get any hope about the role of AI in addressing environmental justice and promoting equality across the continent? So that's be my last question to you.
Absolutely. I think Code for Africa, we are a civic tech nonprofit. So for us, we try and look at what technology can support our work, which helps us have more open data to support communities within the African continent. So by all means, if there is a tool, if there is a way, if there's something we can pull in from technology to move the agenda forward, we do try as our best to embrace it. But of course, responsibly, like everybody should be saying. Anyway, so if I can think of one aspect in terms of, I think, environmental justice / climate justice would be it can really support in having transparent monitoring. And what I mean by that is communities are constantly experiencing just a lot of extraction going on in their spaces, and it's very difficult to actually have this data on time and be able to alert whoever would be able to support them at that point in time. But I think with AI, it would be possible. And how I'm looking at this is, if you're able to develop a tool using all the different types of aspects of AI. So you're incorporating this, you're looking at computer vision, it's part of it. You're also looking at data in terms of your numbers. The fact that you can have different types of data, imagery, analyzed and combined, and you can pick from that and still pick from numbers and still pick from text and be able to bring all this together and have a tool, I think is very, very powerful. And just thinking of something like deforestation, which is a big, big problem. And as I said, there are very many indigenous communities that are actually experiencing this, and they get blamed for it. But maybe if we have something like AI being incorporated, if we use it to be able to do this type of monitoring, where we have drone data, we still have data from our sensors, because we also have noise sensors that can be able to hear maybe someone is hacking, or there is some cutting of trees and felling that's going on. At the same time, we have satellite data that can actually show us the change over time. If we're able to put those three sources of data together, and then of course with technology have either an app, I think that would be very powerful for communities, because then they would just be getting an alert that, okay, someone is actually felling trees right now. I think for me, that's a very big one for environmental justice and climate justice at the same time. I think another one would be, I feel like AI almost, it's almost like how can I say? This is like democratization of predictions. It's still just rests on data again. And when we started this conversation, I said that data is so limited within the African continent, right? And data gives you information that you can act on, and it gives you evidence. So the fact that we can have predictions of something like floods, and this can just be done by us as Africans without having to pay for some expensive application from somewhere outside the world, get a specialist who has been paid lots of money by the government to come and do this service for you. We can now just use AI and ensure we are collecting the different types of data. We can have different parts of different partners, whether it's government, private sector, academia, source the data from everywhere you want, bring it together and see what outputs you're getting. Have some prediction models for the flooding that's going on, all the loss and damage that's going on within this African continent right now. There is so much potential of us being able to actually develop tools that will be able to support, whether it's the affected communities or the specific international organizations or local organizations that actually respond to these people who experience this type of challenges. And because they're becoming more frequent, predictions, I think for me, that is it's a very big thing. It can help save some lives. It can save costs. We can save our infrastructure because we keep losing infrastructure. We can save on food. We can predict droughts. I mean, there is so much support for us as a continent, whether it's in agencies, whether it's in private sector, whether it's for you as an individual, that you can get from the fact that there is the predictive aspect of AI. Yes, I think for me, those two are the key that I see in terms of environmental and climate justice.
Well, you could have just been reading my thoughts the last few months, because I've also felt that we all, in our own ways, wherever we operate, we interact with data. Every person, right from that old lady with a small garden behind her home, interacts with data on a daily basis. And if she has the interest then of developing very simple AI models that would enable her to model her farm and probably conduct prediction, then that would be super. So I'm really dreaming, and I don't think it's a very distant dream, of a platform or an interface that can enable that lady in her own vernacular, using voice, to be able to actually feed data to that platform and develop her own model. I totally agree with you. This has been so eye-opening, so impressive, Alicia. And thank you very much for sharing the story of sensors.africa, from the design and deployment of these sensors to empowering, communities to interpret and act on their own environmental data. We really think this is a very powerful thing. This case of yours certainly demonstrates how AI can be a tool for agency, for justice and equality. the kind of community-centered innovation that our toolbox, the African AI and Equality Toolbox, actually aims to highlight. Really glad that you are here to join us, and we look forward to having a conversation with you in some near future over various topics. Thank you so much, and over to you, Amina.
Thank you so much, Alicia. Thank you so much, Prof. Yeah, it was really fascinating listening to both of you, and thank you, Alicia, for the work you're doing on the ground. It's really transformational, as Prof said. I think, Prof, you've said everything. So my last thing to say is just please join us. We have a final webinar on November 26th, focused on deployment, and in this stage we'll look at what accountability would mean, planning for ongoing monitoring after deployment, how we could think about shared governance, and what are the possibilities of saying no if communities don't want to use the tools. So we really want to explore what it means for systems to be responsive, not just to data, but to dignity, and perhaps even refusal in that case. Thank you so much. And have a wonderful afternoon.